Hello, everyone. So, people online, can you hear me okay? If you could say hello in the chat, if that's the case, that'd be great. Yes, thank you, Javier. Great, so I'll begin then on time, which is nice. Really nice to be here in Barcelona at the Universitat Oberta de Catalunya, or the Open University of Catalonia, or I think it's WAC. Not so good with my pronunciation. But yeah, so I'll warm up the stream and the room with just a short presentation about the theme as it's developed. So if you could show my slides, please. There we go. Yeah, so welcome to the first Algorithmic Pattern Salon. This is something we've been talking about with the co-organizers for quite a while, so it's wonderful to be here now. This is a illustration from a book called The Book of Knowledge of Ingenious Mechanical Devices by Al-Jazari, who was around in the sort of 12th century. And this is just showing some robots making music for a drinking party. He also made robots to serve drinks, and wrote this book to sort of to describe how it works. The water-powered robots, so I guess these are sort of generating musical patterns, which he describes as when an hour has passed, the musicians perform with a clamorous sound, which is heard from afar. So just to make the point, really, this sort of thing isn't new. People have been doing this kind of working with technology to generate patterns in cultural or social circumstances for as long as we know. So yeah, so the Algorithmic Pattern Salon is sort of the first major community event, so great to bring the community together for the first time. We've been developing this theme over the last couple of years. I started a project with some money from the UKRI, the Research Council in the UK, to sort of make space to create so that a community could sort of form around these ideas, which aren't new, as I've already said, but it's nice to start again somehow. The first thing we did was start the Algorithmic Pattern Forum, which you can find. There I met, I think it was there I met Anuradha Reddy, who is one of the organizers as well. I think that's there. Yeah, we had a reading group and things with Ivan Paz, another of the organizers, was part of that, asking questions like, where do patterns come from? What makes a pattern interesting? What are the limits of pattern perception? So I'm not sure we found the answers to all those questions, but you can find some discussion around it on the forum. We also have made a Algorithmic Pattern online talk series with a range of people around patterns in South Indian music rhythms, live coding patterns. So some of the people involved in this theme, including myself, are live coders. So we like writing code to make music and visuals and things for people to dance to and that sort of thing. And Sarah represented those. There's also Becca talking about juggling patterns. And Ron Eglash, who is one of the people sort of pushing forward the idea of heritage algorithms in the first place. So great inspiration. But the other two speakers were Laura Devendorf and Vanel A.A. Noel, who also co-organisers. So sort of met them through that online talk series, talking about weaving and architecture and wire bending, respectively. Another thing we've done is make workshops. So this, again, is from the live coding community, including Ivan, who already mentioned, Lizzie Wilson, who's another co-organizer of this salon, and Dave Griffiths. And yeah, so this was where we were introducing live coders, who's sort of like live algorithmic musicians, to tablet weaving. So this ancient form of algorithmic pattern making, and sort of exploring ideas around textiles and algorithmic music in the same workshop. You can read about that in a paper we wrote about it, called Patterns in Deep Time, which you can probably just Google for if you're interested. So there we are. That's all the organisers, how we came together. That's us smiling after Laura made a joke. Sorry, I can't remember what the joke was. Yeah, so we realised at some point that today and tomorrow sort of clashes with a major holiday in the States, but so we've added extra days to compensate for this, and people will be able to catch up and ask questions in the community forums and so on, which I'll get back to in a second. But yeah, so I've talked a bit already, but haven't really approached the theme itself. What is an algorithmic pattern? I guess that's what we're here to find out. But it sort of brings together two words, algorithm and pattern, which are kind of synonymous, I think. They're both sort of procedures for making something. But we think about algorithms in terms of kind of automation, technologies of control, corporate control in particular, something quite ominous. That's what happens if you do a Google search for algorithm in the Google image search. This kind of obscure image comes up. Whereas I suppose pattern we think of more as something kind of more homely, more hands-on, productive, shareable, culturally grounded, heritage, but also heritage practices which are continually evolving and innovating. Weaving being a classic example. That's the notation for a weaving pattern, a weaving draft. That's the kind of machine. Well, it's not really a machine because you operate it with your feet, but a loom for following that pattern. But then you have something like this, which is by Laura Devendorf, one of the organisers, the AdaCAD system, which sort of takes a contemporary technology of a data flow programming language and applies it to hand weaving. So yeah, look at that amazing system for examples of what you can do with that. I also asked the community for surveyed the community for definitions of algorithmic pattern. I don't want to talk too much, but maybe it'd be nice to bring out a couple of points. It might be something to solve a problem. It involves sort of something that's kind of defined through use, which is interesting. It's about codifying patterns. Chaos comes up quite a lot, like a chaotic relationship between notation and outcome, or slight variations in the starting point lead to very different outcomes. I think that's really key, that you might have a very simple system, but one that somehow is very sensitive to its starting conditions, which I think is the definition of chaos. Something like a recipe. There's quite a lot of nice themes coming up already. You can find a link to the survey, probably in your emails, or sorry, I've sent you lots of emails if you've registered, or on the Discord. So yeah, there's been 9 sessions over 5 days. You can't read that, but have a look at that website to look at the schedule. You can click on the links for your local time zones. And yes, so let's be nice to each other, follow the Berlin Code of Conduct. In particular, we are committed to providing a friendly, safe and welcoming environment for all, regardless of gender, sexual orientation, ability, ethnicity, social, economic status and religion, all that thereof. There's more to it. It's quite a commonly used code of conduct in conferences and events, and it counts online as well as in person. So the presentations that you'll see over the next 5 days come through a review process, most of them, and as part of that review process, the speakers submitted some written texts or videos, which will, after the Salon, after some updates in response to your questions and comments, will be finalized and then published. But you can already read the work in progress via that link, and also it's linked from the schedule for each speaker. So a lot of you are already saying hello in the StreamYard chat. Please continue to do that and ask questions. We'll be able to bring them up onto the screen at the end of each session. There's also the Discord. You'll probably have a link to that, or there's one on the Salon website as well. This is optional. It's not for everyone, but it's a nice, accessible way to continue the conversation after the live stream. So if you're catching up, you can still probably ask questions of the authors if they've logged in on there. And longer term, there's the forum, which I've already mentioned, for longer term discussions. And also a group for sharing references, which we'll link to via email and so on as well. Okay, so without any further ado, I think we should move over to the first presentation, which is from Kadi. So can we bring Kadi to the screen?
Hello.
Hi. Yeah, so would you like to introduce yourself and present?
Yes, I'm Kadi, textile artist from Estonia, and right now I'm at my university, Pallas University of Applied Sciences in Tartu, and I'm very glad to be here, of course. And my presentation is about ongoing process. I was very inspired by 3D printing, but 3D printers seem to be very bad in printing with natural materials, and I don't like adhesives or glues very much. So my presentation is about this process of inventing, participating in hackathons, and trying to find people who could help me with my crazy ideas. So please start the video. So, inspired by 3D printing, and this is the first prototype we built in 3 days in 2016. And the idea, you see that warps are hidden in the tubes, and weft is guided around those warps. And afterwards, the supports are removed. So I feel very nostalgic when I look at it, because you see that it was made from plywood and drawer sliders, and all the persons who participated were volunteers. So these are the steps of multi-weaving here in pictures. So again, warps put up, then weft between them. And why did I call it weaving? So when you look at ordinary weaving frame or tapestry frame, then the warp goes up and down. And the weft goes between warps in layers. And then magically, what I did was I did the warping in the same way, but nails in the frame are replaced with rigid vertical warp supports. So far, very much like weaving, but multi-weaving is that I can put multiple rows of warps on a field. But still the weft is guided between the warps, and they are in layers. So how is multi-weaving different from weaving? When you think of the traditional weaving, then you have those warps that are sometimes up and sometimes below the weft, and the weft is in the shade. With multi-weave, the shade or the path for the weft is kind of floating, and the weaver can decide which way the weft goes in every certain points. And also this illustrates how weft can move around two neighboring warps in various ways. And these are some variations for how warp rows can be placed. This also kind of differs from what is in the ordinary weaving. So Anna developed this beta version of a program where weaver can first decide where are the warps, active warps, then draw the path of the weft between the warps, and then the program generates G code from this pattern. And then it was possible to visualize it in a free toolpath simulator online. And this was some second prototype of multi-weave. So always again done in a very garage like thing, but we kind of searched after the design of warp supports. And I show you some names of nice people who mostly worked without any compensation. So I'm very thankful to them. But in 2021, we decided to develop this system of making textiles into a craft tool, because it seemed quite overwhelming to start with like machine building. But I thought that there's so much options we can try out by hand, as we are following the same system of weft placement as this machine did. And this is now how we end the warp loops, connect them with each other. So, and here I show how we removed the supports from the textile and how this looks like. Those supports are laser cut from plywood, and yes, the thickness of the material depends on the height of the supports. So next, things go better when you share. So I contacted my friends from Swedish and Latvian and Finnish universities, and we made a project that I sent the tools and video instructions because it was COVID. And then in every school, the students tried to make we made those samples and art pieces in this multi-weave technique. And then we had in 2022 a big exhibition here in Tartu. And Annette Nina was the first who made her graduation work on the theme of multi-weave, and Riina Samuelsen from Estonian Academy of Arts was the first MA student who made the theme her degree theme. This is the piece. And many thanks to everybody who have participated in this.
Wonderful. Thank you very much, Kadi. So we will save some questions until the end after this session, but it's really nice to have that as the first presentation, such beautiful physical algorithms. So next, I'd like to invite, I believe next it's Mika, yes, from Berlin.
Hello.
Yeah, would you like to introduce yourself, Mika, and share your work? Thank you.
Okay, hello. My name is Mika Satomi. I'm an artist based in Berlin, and I work mostly with electronics, textiles. Yeah, sometimes more with technology, sometimes more with textiles. But yeah, that's my working field. And I was really excited to hear about this algorithmic pattern salon event, and I wanted to submit something, but I didn't really have I didn't really make a project for a submission, but rather I looked into what I have been doing, and I looked into what I could think of with this topic of algorithm and pattern. Now I would like to put my slide on. Ah, yeah, it's on. By the way, is it possible to see other people just by chance? This on the side or something? If possible, would be nice. Okay, I guess not. Yeah, so now I'm just talking a little bit just into the void. I hope there is someone on the other side listening. Anyway, so I'm starting now. So I thought about looking into what I have been doing and think about how I could respond to this idea of algorithm and pattern. And I would say my working field is also artistic, but much more in the DIY field. And I think my practice is very much based on doing it myself, or doing it yourself, doing it together. It's not so much about thinking about it, but rather just to do it. And that's also my approach to textiles and electronics. Both of them, I don't really have formal education in textiles, but I just tried out many different things. And when I was looking into what I have been doing in terms of algorithm and textiles or patterns, I started off with this quote from Lars Halnes. Lars is a mathematician. He is also a professor in Swedish School of Textiles. And he's a person who likes to throw into this kind of riddle to us to think about something. And here I started to think about the textiles or textile thinkings, as he states here, as there is no form, there is no material. There is only form, there is only material. Form and material collapse into definition, the textile design formula. All of this relates to a design practice. It is thinking within the process of designing. So with this in mind, I started to look into some of the projects or experiments I did. And I thought about what does it mean actually when it comes to algorithms and textiles. So the first example is this mini project, or more like mini experiment I made together with others, which was inspired by the koginzashi, which is a sashiko embroidery technique from northern part of Japan. And this one is very particular among this sashiko embroidery because instead of looking into the shape of the embroidery, they count the stitches. So all the patterns are based on the countings. But the countings are fixed, so it's not generative. It's always the certain pattern of numbers that you count the warp of the base fabric, and depending on this, you stitch. And so I was inspired by this, but I thought instead of using the fixed pattern, what if the pattern could be generated? And therefore, I looked into cellular automata. This is my first attempt or first tryout of making cellular automata Rule 30 with a cross stitch. But I was just kind of adding these stitches by following the instruction or following the cellular automata calculation. And it looks like a cellular automata, but actually if you compare with the actual Rule 30 cellular automata, you see the differences. And by the way, cellular automatas are always, how is it, finite? So if you start with the same position and with the same rule set, you should always get the same result. But here it isn't. And easily guessable. The reason is because I made mistakes. And I thought you could just say that this is not the cellular automata because there's a lot of mistakes in it, or it's just simply a failure or the mistakes. But I thought it's interesting how these mistakes are happening here. And this is also related to its physicality of it, that it actually is made by human hand and therefore human errors are occurring here. And also it involves a lot of times and the environment that the embroiderer is experiencing at the time. So maybe someone talked to this person and then there is a mistake happen. There was a break in between and the rule sets were forgotten, or simply this person was just not paying enough attention. So all these things plays a role in these mistakes. And I don't know, I couldn't just dismiss this as just a failure or the mistakes, but I feel like there's something interesting happening in this comparison between the algorithm or cellular automatas made by hand in this kind of physical form and looking at the algorithm of cellular automata itself. Now, the second example is a from a workshop I did together with students from Weissensee Art Academy in Berlin, textile department. And there in this workshop, we first looked into how an information is coded into binary numbers. And this was inspired by a workshop called Making Core Memory Workshop by Danielle Losner. And in this workshop, she looks into just one set of 8-bit binary code that is produced from the ASCII code of the alphabet and code into kind of series of one-dimensional bead set. But then we thought of what if we, instead of this bead with the one set, if we could use this same idea of conversion into weaving construction or structures. And interesting thing is, so often this 8-bit set of 8 binary numbers are used for coding or information package. And 8-shaft or 8-shaft structure for weaving is quite common set for textile. So we thought maybe it's interesting to look into this. And as we often hear also the textile and weaving connection of 0 and 1 to the binary code of the 0 and 1. So this is the ASCII code, perhaps many of you know of it. But when we tried to just convert the actual ASCII code of the alphabet into a weaving structure, we immediately encounter these problems because the ASCII code, you don't change, like you don't have to change all the 0 and 1s constantly. But in the weaving, if you do that, you can't basically create in a fabric. This fabric would fall because the some warps are not woven in. So here, Cecilia and Jinu have come up with another solution to actually not to use only just the 8-bit code into a single row of the weaving structure information, but turn it around and then make it 8 by 8. And by using it by kind of mirroring from the axis, you can then create a weavable structure always, no matter which combination of these 0 and 1 data you have. And this is some of the woven example from this conversion. And later on, Cecilia went into now expanding this idea into crocheting. And here she's converting the alphabets, again, the 0 and 1 binary code into a crochet structure. And here, interesting thing is crochet is then not only 0 and 1 or two possibilities. Actually, there is so many different kind of stitches, so she had to choose how to represent one and how to represent 0, in her case, single stitch and double stitch. And here are some of the examples she made from word Leben, life, leaf, and Sterben, deaths. And here, what she said was interesting. I asked her why she chose these particular words to do an example or to do a tryout. And she said she was interested if the textile that is produced from this word, which is very opposite meaning word, would actually contain or give you any feeling of the original meaning. And well, this is for you to think about it. Of course, if you didn't know the meaning of it, I don't know how much we will feel that. But it's just an interesting idea to think about something that is coded, how much of the code itself contains the meanings and value of the information within. So that was very interesting thoughts, I thought. Now I'm running out of time, but I have the third example. So third one is my project example. And here I tried to kind of physicalize the artificial neural network into a textile. And here is the Python code of simple artificial neural network. And as much as we think of artificial intelligence as some kind of being or some kind of intelligence or agent-like things, it is actually a simple algorithm. But then this algorithm is kind of made into, or how do you say that, conceptualized into this network of neurons like this. And therefore I thought about, okay, what if I kind of take this more physical metaphor and then create actual physical network out of these algorithms. So I put each of these neuron functions of firing into a microcontroller. So each of these microcontrollers are doing just this one set of calculations, and I connected them as a network so that it will formulate or create a neural network. And they are exchanging the data over the light through these optic fibers. And here is the result, like one of the results of these neural networks. So when these microcontrollers are firing the neurons, then the light is lit up, and you can see also how much it's lighting up and then how much the other one is taking in, and then further passing on this firing or not firing. So this was kind of interesting ways for me to think about this very ungraspable algorithm such as artificial neural network into a physical form to kind of my attempt of re-grasping this concept itself. But also I made this big embroidery of neural network into a garment so that I can wear. And here I also wanted to just simply experience this physicality of it on my body to see how I feel, how it can be grasped, also with my own movement and I don't know, almost like being an agent itself. So now I would like to come back again to this quote from Lash once again. And time's up, so I just go quickly. And a little bit of thinking and proposal is that maybe there is algorithms that are expressed in numbers, but there are also algorithms that are expressed in textiles. And maybe also there are algorithms that are expressed in other types of practices and physical forms, and we just don't see them as, or don't call them as algorithms. But once we start to consider them, maybe there is another way we can perceive them, or we can think further with this idea and concept and definition of algorithms. That's all from me. Thank you.
Thank you so much, Mika. We've had some issues here, but I think actually, Ámbar, you're ready to present. Okay, yeah. So Mika, we'll bring you back with some questions after this presentation. Thanks. So yeah.
Hello, my name is Ámbar Tenorio, and I'm here to introduce some work we've done to use the same patterns to produce audio and visuals with two different languages you might know for live coding, which are Hydra for visuals and Strudel, that is based on tidal cycles for audio. How many of you know these programs, Strudels and Hydra, or some of them? Cool. So we developed an extension for Hydra that brings Strudels into Hydra, and also we developed an integration, native integration of Hydra in Strudel, so we can use the same patterns. And it's kind of fun because you can always try to do visuals to match the rhythm and to respond to the audio input. But it's much expressive if you can use the same patterns and change the pattern and the music and the visual changes. So without more previous talk, I'll show you the examples that are included here in the in the submission, which is cool because it's an interactive submission. You can play them in the conference website. But let's yeah, both of them. That's what I love about Hydra and Strudel, which is like people that doesn't know how to program can start playing visuals or audio just from their browser, from their mobile phone, changing some numbers and not installing anything. So let's go to Hydra example, and be careful because of the sound can be loud. Okay, good. So you see here 4 different Hydra visuals that are responding to the audio. Maybe you can make it a bit louder. And the pattern that is playing is just a note 3, note 4, note 3, note 5, note 3, note 6, note 3, note 7. And this is creating triangle, square, triangle, pentagon, pentagon, and so on. Let me stop this and go little by little. So if we write a pattern that says 3, and then in this minor and major signs 4, 5, 6, 7, if you know Strudel notation, this is a pattern that is just saying it will play first the 3, then the 4, then the 3, then the 5, 3, 6, 3, 7, right? And we can make this represent a shape. Let me. And this is the shape, but we can also play this pattern using a C major scale. I don't know if you see the code. I'm just playing the same pattern here, and it sounds the 4th note of the C major scale, then the 5th, 6th, and so on. We can add some colors to this. We can add some percussion patterns and say that when the bass drum is playing, we will make some modulations to this. Yeah, we need to render. So when the bass drum is playing in the pattern, we have this modulation to the triangle, and we can do some other effects, right? If we play them, the four things that we played, we can see these different things. And this is just a Hydra extension. If you go to Hydra/dev, you have here the library tools. And to use this example, you can just go to the Hydra Strudel extension and select the first example, which is pretty much this submission to Alpaca. But we also did this for Strudel, so we included Hydra in Strudel. And again, you can play this in the website. But let's see the example in the full screen. I'm sorry if my voice sounds like this is because I'm nervous. And I don't know why, because I should know this thing by heart. So, but you know that visual representation of music is not only these shapes and colors. Usually we represent notes and pitches with the height, yeah, in the traditional pentagram. So we can keep doing things like this. Strudel probably is the first tool I should open because it has the highlight of the pattern syntax. So when I play a code, the note that is playing is highlighted like this. You see there traditional scale, traditional C major scale that goes from C to C. We see that if we change the speed, for instance, here, it will change everything, the music and the visuals. How the notes are going up and I wanted to go slowly, example by example, but maybe it's not needed. If you see the first scene, I am painting the notes from C to C, depending on the height. Next, I'm adding a triangle that changes color every 2 bars. So that's a really cool thing that you can do as well, like to synchronize the tempos. Then in the next one, what I'm doing is adding some modulation when the bass drum is playing. So you see that it's a bit like twisting. And finally, this one. I don't know why, maybe because we're not making a lot of noises. But, oh no, we need to init the Hydra with audio. So we have audio responsiveness as well. Okay, so it's not, yeah, it's, okay, yeah, that's because I'm using Strudel current version, and this is only in my local computer because it's not deployed yet. So let's change to localhost and have the audio responsiveness. And I think I'm finishing with this. Probably the discussion is how could we make some more cool things with this type of patterns? Because as you know, Tidal is really specific for patterns. And we could use them not only to synchronize music and tempo and rhythm with the visuals, but maybe we could use the same patterns to, I don't know, paint the screen, saying, okay, red and blue, red and blue. What could we do with these kind of patterns? Let me just show you the audio responsive version, and let's close with this. It's just a little trick that I'm not gonna show you because I have to set the. I mean, if we have 1 minute, I could do it. But whatever, it's just a trick that Hydra knows how to respond to the audio levels. So I don't know. I hope you liked it. I usually performed with a Hydra a browser open and then a semi-transparent Strudel window opened in top of it. And this is kind of fun to do it together. And I hope you have fun as well with this.
Thank you so much, Ámbar. Yeah, if you want to prepare that last demo, then maybe we can show it right at the end. So yeah, should we bring Kadi and Mika back to the stage? Welcome back. I can see we've got lots of comments and questions. Let's see if I can find a nice one first for Kadi. This is a nice question for everyone, really. So it's from, sorry, we've got infinity there, but yeah, there's some feedback involved in what we've got set up here. So yeah, question on multi-weave. How predictable is multi-weaving? Is it something where you write down the pattern in some notation and easily visualize what happens, or is there room for surprise when you actually make it? This is such a nice question about patterns.
Yes, of course, we can't do without surprises. So this is one point of it. The surprises get less when you know how the materials act, what you use, and also when you understand how to control the tension and how not to expect that big weft floats form a very strict and rigid structure in the end. So, but now I have a course with our first year students, and there we in fact started so that I gave some kind of visual codes, how they should, what are the warp row patterns, and then they develop their own density and what materials they use and so on. So let's keep the surprise part still active there.
Very good. So a question for Mika. How did you make the choice to use optical fibers in the neural network piece? How do you interact with it?
Okay, it's a very specific question. So the use of optic fiber for that project was because I wanted to see this firing of the neurons and how they are functioning in a way. So I wanted to kind of physicalize and visualize the functionings of the neural network. And that was the reason why I choose to use the optic fiber. And then how do I activate it? There is actually, there is 3 versions of it. The first 2 were connected with sensor gloves. So I could move my hand and then I could train it with it. So it could recognize certain hand gestures. And then the last one that I was wearing, that one is connected with a full body sensor suit that I'm wearing underneath. And it can recognize few of the poses that I'm doing, or I trained for it.
Cool, thank you very much. It's nice how both of your pieces were so physical as an introduction to this salon. The kind of physical aspect of the outcome. But then I guess with Ámbar's work, this is also very physical. I suppose sound is really a form of touch, and of course visuals also have the physical aspect. I guess it's quite an interesting juxtaposition, which we see a lot in this salon. I think textiles being shown next to what we would probably think of as digital work. How do you feel about this connection between physical pattern making and what you're doing with your Synthesthesia project?
Well, I'm thinking we are using the same patterns, and what we did in our work is connecting the same pattern language for patterns to produce 2 different types of outputs. But I can think of using the same rhythm to move a robotic arm and wave something. So you could write in strudel, okay, move up, move left, move down, move left for 2 movements, and that's really easy to write. In this notation, to make repetitions, to make that speaks about rhythms, to speaks of durations, and I think why not next. So will be a robotic arm waving something that is sounding and that we are painting in the screens. I don't know. I have this. Yeah, you can think in terms of patterns for different types of production. Yeah,
predictable for sure. Yes, there was a comment from Ivan robot weaving patterns. So Mika, you have your hand up. I notice you're also muted, but yeah, there you go.
Okay. Yeah, I wasn't sure if I'm allowed to ask questions, but I thought like how you started off with this definition of algorithms and pattern and I was a bit surprised to see that the pattern being connected with crafts and how to say, more practice. I feel like pattern can be also very much in this kind of conceptual or more like algorithmic algorithm itself. But when it comes to physicality, I had this, like when I was writing this text, I was thinking about the, often we hear this like algorithms just applied to the textiles. So, okay, there is this algorithm, let's do this on the textile. But actually it hardly ever works because there is a physical construction of it. Like you can't weave it in a certain way, or you can't insert fibers in a certain way, or there is always this physicality of it that is a limitation in one way, but I feel like almost that itself is an algorithm, where that plays a role in it for what comes out. But then by looking at Ámbar's presentation, I felt like also there is this kind of limitations and frameworks like C major, or so even if it wasn't the physical things, there is always something that is playing along with the algorithm that is not just the algorithm being the pattern. So I just wanted to bring this up as maybe something that maybe others have an opinion about.
Yeah, do you want to respond to that? Or Kadi, do you have any thoughts?
Well, yes, but my thought of algorithm is perhaps more of a method that that I use in my inventing projects. That they go like you think what the problem is, then you imagine the result, and then you divide the problem into parts and try to find solutions to those problems. And that's I certainly in my kind of working, I rely much on right kind of people to talk to. So in my inventing algorithm, I have several people who I always can turn to and ask what would the solutions be. So my idea of algorithm is the the method of getting things done.
Yeah, maybe the practical side, but I guess you could see a pattern in the same kind of light. I think the word pattern is, and you're right to pull me up on it, Mika. It just has such different meaning in different contexts. If you speak to computer scientists, then they'll think about ways of doing things in object orientation. If you speak to a composer and say they're making patterns, they might be really offended, or if they're a minimalist composer, maybe not. But and if you talk to a designer, they'll talk about wanting to break patterns, so start with a pattern and then break it. And yeah, and then mathematicians, if they say they've found a new pattern, then that's like a real life event for them. So yeah, it's interesting trying to use these words in these very interdisciplinary contexts and still somehow understand what each other means. Okay, let's see what other questions we've got. So there's some quite technical ones. A lot of these we'll save and then make sure there are responses to them either in the Discord or elsewhere. But this question's nice. It's again for Kadi. I love the aesthetic of the MultiWeave tool. I'd love to know more about what the benefits and drawbacks of the machine versus working by hand. Did participants try both, or was it shaped by restrictions due to coronavirus?
Yes, thank you for the question. All the participants in this exhibition project, they worked by hand. And my idea was, although I sent the tools, but the idea was that everybody makes their own tools. So in the end, I encourage them to use barbecue sticks and cardboard, and we get very cool variations of this warp support systems. The benefits and drawbacks, of course, the benefit of working by hand versus the machine is that hand is much quicker. And so I got so frustrated that although I love the machines and I love the DIY thing about it, but it is so slow. So this was that I'm very happy with this process now that we try to build those MultiWeave structures by hand. And yes, this COVID shaped the participation or the organization of this exhibition project. But my colleagues told me afterwards, when they saw the works from Sweden and Finland and Latvia, and they said, "We are very glad that you didn't have possibility to travel, because now every country gets its own version of MultiWeave. If you would have been traveling, then it would be all the same." Yes.
Great, thank you. And here's a question for Ámbar. I can picture how tidal patterning can manipulate parameters of Hydra's functions, but how does the feedback, so characteristic of Hydra is translated in pattern transformation. So how do the patterns come from Hydra into Strudel, I think is the...
Yeah, so what we have chosen is to use Strudel patterns, which is a language that is much more expressive. In Hydra, what we had previously was arrays that you could modify the speed by which the terms of the arrays were changing. And I think that's it. For instance, if you wanted to repeat twice the same color, you would write in the same array like the value, then the value repeated, and then another value. And that's not a really expressive language for patterns. So what we do is use inside Hydra, we can use the Strudel pattern and create things such as So we can add to every note that is sounding the root note and the fifth note of it, and then Hydra will, because it's using this pattern, will respond to that. I don't know if it will work. This is live coding, but yeah, here here you go. Hopefully this, make it faster. It's live coding and it's not working, but you see it's changing the octave here, right? And Hydra is responding to that. It's just okay, so like maybe the easiest thing to see is that if we change the speed, if we change the speed, the speed of the visuals is changing because it's following the pattern. Probably let's paint the simpler version, which is just the notes. You see there was a glitch there, and actually Hydra responded to that glitch in the computer. It's because it shared the same clock and the patterns is the same object. So whenever it changes the pattern, the Hydra and the music changes. Okay, I don't know.
Thank you very much, Ámbar. So we're squeezing one more question, which is for everyone. Oh, in fact, that is not the one I wanted to do, one that was for everyone. See if I can find it again. Okay, no, I can't. Oh well. Yeah, I've completely lost it. Let's try one more go. Maybe if I search. No, it's disappeared. Oh well. But in fact, we're up against time anyway. So yeah, maybe we'll just leave it at that, and we'll assemble all the questions and share them and make sure they all get responses. So thank you very much for Mika, Kadi, and Ámbar. So the next will have a break of half an hour, and see you at 3:30. Oh no, it's 3:30 UTC, wherever that is in the world. Have a look at the schedule to find out where it is. Okay, thanks again. Thanks everyone. Bye. Should we just have a quick mic check? Just to check your mics are working, Julia and Emma.
Testing, is it working?
Great, yeah, perfect.
Hello, am I working?
Lovely. That's great, yeah. So, yeah, so we'll be back in 9 minutes. I'll take off the stage again. Great. And check the private chat for any messages.
Oh yeah, there it is, yeah.
All right. Hello, everyone, and welcome back to the Algorithmic Pattern Salon. And for anyone who's joining right now, welcome to the first ever Algorithmic Pattern Salon, where we are bringing together a great set of people who are really passionate about new ways of pattern making, whether that be contemporary ways of doing it, contemporary techniques, or heritage techniques. And I am Anuradha, and I am based in Sweden, and I have a background as a researcher, and I really like patterns, which is hopefully reason enough to be here. And yeah, so today we have an exciting number of talks, we have 5 talks in this session. 3 of which are very centered on textile making and the making process of it, and reflecting that making process in relation to the act of production, thinking about, reflecting from pattern making point of view on thinking about the cognitive processes behind it, the emotional, and also thinking back on how these textile processes were made in history. Super exciting. And we have 2 more talks, which are more about the live coding aspects, about the real-time performance of digital materials when you apply algorithmic techniques on them and then generate interesting sequences of patterns. So yeah, stay tuned. And so this is how we will do the sessions today. First, we will run through all the sessions one by one, and then we will leave the space for discussions. So keep an eye on the chat and make sure you write your questions there and vote for questions you like. So without further delay, I would like to call upon the first talk, which is titled the Crochet Protocol. And I encourage all the speakers to first introduce yourself, and then, yeah, we'll load the talks.
Yes. Hello, I'm Julia Vollmer, and I'm from Germany, and a digital media artist and student who likes both crocheting and code. So that's why I'm here, and patterns, and I'm going to show you my project, the Crochet Protocol. So, can you see my first? Okay, great. So the Crochet Protocol was made in 2022. And it's a device, a bracelet with 3 vibration motors that gives me pattern instructions through tactile and sensory feelings. And the patterns are deconstructed into several smaller steps. And yeah, how I came up with this whole thing is that I enjoy both crocheting and code, and always wondered what are the similarities between crochet and code, and how I can translate between them back and forth and vice versa. From there on, I also thought about how can I follow a pattern created by code? How about I make a device that gives me these pattern instructions, maybe even through tactile signals? And with this, even more questions arise that, like, the question, how does it even feel like to get the instructions, and what are the dynamics between the device, the pattern, and me, the wearer? Within crocheting, it's widely agreed on, as Carrie Carpio states, a machine that can produce true crocheted fabric, therefore means to be devised, that real crocheting has to be done by a human, giving way more interest aspects to this dynamic between the wearer and the device. Because for patterns produced by code, there has to be a human involved to make them. So where did I all start? So I researched about the computational aspects of crocheting and did my own experiments, where I looked both at a more visual programming language like processing and tried to code from processing sketches. But I also looked at a less graphical language like Python and made a code based on crochet instruction, and then again followed the crochet instruction from that code. So all of these experiments, I kind of realized that all the crochet stitches are on a higher level, and if you look closely enough, there are more movements involved. For example, if for the chain stitch, you first loop and then you pull through, or for a slip stitch, you insert your hook, then you loop, pull through, pull through. So by looking at a lot of stitches, I broke down crochet instruction into 7 basic movement steps and made my protocol consisting of 7 steps that you can see on the right here. When making the patterns with this protocol, you have to follow basic aspects of making a 2D crocheted item, as you first put the yarn over your hook, and then the actual pattern making a protocol starts, where you do multiple chains and then do several rows with different style of stitches that consist of all these 7 movements. And in the end, when you're done, you finish it off by pulling through. Here you can see one example of the visual representation of the protocol. Like all of these, the number, the words, the sign, and the crocheted item is based on the same pattern, and the item was crocheted while wearing the device. So the device itself consists of an ESP32 and 3 vibration motors. And the 3 vibration motors are placed around my wrist in some sort of distance, because if they're too close together, it will feel as one sensory feeling and it's very hard to distinguish them. And these 3 motors give me the instructions in a rhythmical time. And I decided on 3 motors because for 7 instructions, the minimum amount needed to represent 7 instructions are 3 motors, and it will keep the device in a smaller variable size. So how did it actually feel wearing the device? It does require a bit of crocheting knowledge and an adjustment period where I'm learning the protocol and learning how the instructions, each of them, feel sensory. At first, it was a bit hard to distinguish the instructions, but after several attempts, I understood the vibrations more and more, and it actually felt quite exciting to get the instructions right. So while wearing the device, I did notice that there were predictable patterns coming up. So it was very easy to follow. But then in the end, since I don't actually know what happens next, there was always the insecurity that the pattern might be broken or something very unexpected happens, or I'm like not able to keep up with the rhythm of the device, kind of also giving me the freedom, or like I needed to make quick choices and own decisions against the instructions, adding in also human error within the pattern. So with this tactile instructions, what are like the difference between normal visual crocheting pattern instructions? I could like identify 3 major ones for myself. On one hand, I cannot predict what happens next. I cannot look at it. I have in the moment, and I can't comprehend the pattern by looking at the whole script or like the whole pattern. And with this added temporal aspects, it's also something that happens in the moment. There's no before and after. Like I can't go back and look at it. And it's also quite interesting that with this crocheted tactile instructions, the instructions itself are very close proximity, situated in close proximity to the actual crocheting. Like I'm taking away the visual layer, and then it's very close to where the actual event of crocheting happens. The instructions become part of the activity of crocheting. It's like one tactile event. So after wearing the device, I did notice that through the whole experience of wearing it, I'm not focused on the finished item. It's more about the event of crocheting itself and following the pattern. And when I'm like taking off the device, the vibration keeps with me, kind of like a phantom. And the event takes a longer time to finish. It's not done with the item. It continues. Also with the device, I could look closer into the stitches and also felt a closer connection between crocheting and coding, as I'm again translating the device's instructions into my own body movements. So yeah, that was kind of how it felt like, and it further proved to me that crocheting and coding are very closely related. Thank you.
Thank you. That was great. All right. So can we have the next talk, live coding physical MIDI devices using MicroBlocks? This will be one in Barcelona. So yeah, take it away.
I'm a developer of Snap and MicroBlocks at SAP. These are two programming languages, educational programming languages to teach programming to different audiences. I'm a small talker at heart, so I've been live coding forever, although not music. I'm an ex-musician, although thanks to this current work that I'm going to show you today, I guess I'm not an ex-musician anymore. I'm probably a musician again. I don't know. Who knows? You'll have to judge that. And then today my talk is going to be about MicroBlocks and its new capabilities for making music. So I'll explain shortly what MicroBlocks is. You can find all about it at microblocks.fun. That's our website. But basically, it's a visual language. It uses visual blocks to represent code instead of text, a la Scratch, Snap. This is no coincidence. The main developer of MicroBlocks is John Maloney, who is also the creator of Scratch and its main developer and architect for the first 12 years, I think, or so. And it's a live programming language. That means that, you know what that means. But changes are reflected instantly, right? You don't have to compile or any of these spooky things. It's autonomous, meaning that once you're done with your code, you can unplug your device. I didn't say, it's very important. It's a language for microcontrollers, not a language for your computer, but for microcontrollers, for devices like this one. I don't know if you can see it. And so it was very important for us that this language was autonomous. So when you're done with your work, you can disconnect your board, connect it to a power source, and it will keep on working the same way it was before. And it's a parallel language. You can write several scripts, several processes that run at the same time, and you don't have to worry about concurrency or any of these things. It's handled automatically by the virtual machine. It's also portable. By having a virtual machine, we made it possible to run the same code in a wide variety of devices with even different processor architectures and so on. And let me show you what's part of what's new, just the latest things that we added to the language. And those are basically a bunch of libraries. We have a new MIDI library. We have a new rhythm library. We have a new scales and chords library. And this is what I'm going to show you today. But I've been obsessing with making music with this thing for a couple of months now, so I couldn't stop there. And I made a square wave chords library and a chiptunes library. I think that's, yeah, that's it. So let me show you. So this is MicroBlocks. I have a board connected to it, and this board has a tiny MIDI module connected to it. So I'm programming a board that's going to send instructions to a synthesizer, okay? The way I do this is I use the MIDI library and I go play one note, right? So let's start making things with this. I can also play a drum, right? So let's start making some things. I will use the rhythm library and I will set my tempo, I will set my time signature, and I will set up a pattern, important for this conference. And I will start playing. So now something is playing in the background, but we have nothing in the pattern yet. But the pattern is already cycling. So what are we going to play? Let's see. We'll say at every first beat of every bar, I'm going to play a drum. And that's going to be a acoustic bass drum. And then I'm going to play, I don't know, a hand clap at beat 3. And then since I'm a bit tired and running out of imagination, I'm going to just add a bunch of random drums, you know, from the first possible drum to the last possible drum. And I'll do it at bars 1 to 16, but not all of them. Every random 1 to 5, let's say. So this gives me different amounts of differently spaced bars. And I'll do it in different beats as well. And for that, I'm just going to shuffle a list where I'll have 1 to 4. Those are the beats in a bar, right? I will shuffle that, and I will just take, I will just take, copy, where are you? Here. I will just copy the list starting from, right? So I get either 1 element or 2 elements or 3 elements, and they're at random. So I will add that to the beats, and I'll do that a bunch of times, 10 times, let's say. Here's my random pattern. That's how my music begins. So this is great. You can already dance, but we're missing some music, some notes. So let's take a variable. Oh, shoot. I should have created that first. So here you'll see MicroBlocks was not originally designed to make music. We found out that the tempo keeping capabilities of MicroBlocks are great, but some things require stopping all processes. And one of these things is creating a variable, if it's a global one, because that can affect processes that depend on the variable, can affect functions that are using this variable. So we have no other way but to stop. So I'm sorry, the music will stop. But we'll start it right again, and you will not notice. It's a different pattern now. I don't like this one. Let's make a new one. Oh, of course, because I threw away the code that made. We need at least something that we can recognize. So yeah, at least we can recognize that. Okay, so I will add a baseline every first bit. And the way this baseline is going to work is I have a variable where I will add a chord progression, and that's going to be a slightly random based chord progression based on the circle of fifths. That's 4, 5, 6, 7, 8. That's okay. Let's add the pattern here. Actually, let's shuffle it. Let's shuffle this chord progression. And now we have our chord progression. How is this baseline going to work? Let's see. So we have our pattern. We just need to arpeggiate over the current chord of the pattern. So we will use this circular item block. We'll get the circular item current bar of our pattern. What circular item does is it wraps around, right? There you go. It's one different chord each bar. So I will arpeggiate that, and we'll do rhythm. We'll do triplets of quarter notes. So that's going to be the duration of the arpeggio, of each of the arpeggio notes. And then just to break it a little bit, we'll do 1, 3, 2 as the order of the arpeggio, so it's not boring like it's going to be a little bit more. Okay, this is not a bass though, so let's choose a bass. Let's select instrument bass number 2, for instance. Okay, I swear this is a bass, but it's it's way too high pitched. So we have to transpose what we're doing. Let's transpose this circular item, which is the chord, 2 octaves, and okay, we can even make it longer, right? It's yeah, Grandpa's anniversary tomorrow. Okay, so we have the bass line, and I'll try to make some chords very quickly. We'll add them at beat 3, and chords are going to be, since we already have the circular item, we'll reuse that. I can throw this away, it's already playing. And the only thing I'm going to do is I'm going to play this, and I'm going to play it for half time and on channel 2. And we can select, I don't know, a guitar for channel 2. Okay, so you see how this thing works. It's very additive. It can be very chaotic. Your screen may fill up with a lot of stuff, but the nice thing is you can throw all of it away and it will keep playing, right? So you can reset your space from time to time and sort of continue working on your piece. That's pretty much all I wanted to show. I have how much? 1 minute left? Okay, that's right enough. I just wanted to say Enric, Sintlali, and Ivan are the reason I'm doing this stuff, and I say thank you. Thank you for making me poorer. This is my desk. But thank you also for making me happier, because I'm having so much fun these days with this stuff. And I will play, yeah, just 1 minute of some of the things I've been doing. It should be playing already. Okay. So I've tried experimenting with some different genres. I'm originally a reggae guitar player. The first tune you heard was a reggae. This is sort of a Latin rock. Then I went all Martian on trying different sounds and patterns. Then I discovered chiptunes. So I started generating sound right on the microcontroller. And then I started mixing the two things together, and I don't know what's next. I tried to make some jazz too, which is, I mean, this is full chiptunes now. This is chiptunes as well. That's the last one. That's mixing chiptunes and MIDI at the same time. And that's it. Thank you very much.
Thank you so much. That was excellent. Like, it looked like magic. Magical things were happening. All right. So the next talk is called Digitized Surfaces, Located Skins that Dataify. Yeah, could you maybe say could you introduce yourself, please? And while I pull up your video.
Can you see? Okay. Thank you very much for the opportunity to expose my work, my last work. My name is Maria Jose from Chile. I am a media artist and visual artist. And my presentation could be in Spanish better or not? I will present my last work called TTT, Textile, Texture, and Technology, from the post-ancestry world. This kind of project corresponds with to last 3 years, but this project specifically is 2023 year. It will vestibles in a research mind platform from Chile. It's a textile, wearable, culture, and technologies with a very, very important in tradition, historical tradition in textile techniques, because the ancestral life is very important for these current cultures in Latin America. Web ancestry system meanings to generate a landscape of interaction based on the intersection of our cultural origins and our current ways of relating to the environment, others, the other from touch, in order to generate an encounter with a symbolic rhythms, which in turn and means of transmission, interaction, culture, and society. Technologies and techniques that mark, that identify a social and individual body and make room for a place to rewrite, feel, and transform. This wants to say for this project, the important thing and concept are the relationship with between physical and digital world in the same times, because the patterns in algorithmic patterns maybe are the digital lectures from the textile in physical interaction. Sounds for this project, in special for this project, consists in horizontal textiles based in climate colors of our territory, of Chile territories. The colors of web these textiles corresponding in a north zone, central zone, south zone, and austral or extremely south zones, and has 24 zones for touch. Okay, for touch with hands or other things, and this touch indicates the patterns in a digital world. Okay. These are textiles, for example, of a function with a computer screen in a real time touch, and to show now the solution of now will be with pom-pom with a borla. Is an ancestral termination for textiles, Andean and Mapuches. Mapuches not much, but Andean textiles has a termination called borlas. Pom-pom is a 60 grades borla. So these terminations, terminal details for textiles are chosen in a screen. With depends of angle of touch textiles, physical. This is a functions of from the touch pressure of the textiles. And when I click from the computer to the numerical values, the data are transcodified immediately to draws lines draws with an angles. Okay, and in the future I want to make this as a new form of writing. Horizontally, symbolism in the Chilean territory, and the Andean techniques is very inspiration for me for two way of digital present the touch data, physical touch data. Wrap face techniques. These textiles was webbed in a Mapuche and Andean techniques, very artisanal process, and the pattern of the pattern of touch zone 24 are webbed with conductive threads, and above the textiles there is a very complex system of Python, MicroPython started software. It's made in Python software. For me, it was very important to learn Andean and Mapuche handmade techniques, because these techniques has a very complex systems of transmit information. The base of my project now is textiles. Has an interface for transmit information visually, and in the future also maybe sound data, sound with an haptic for transmit in a sound ways the data. Interactive, because I think the interactivity could be a language or a system of some kind of language through traced sign or reaction from a support, and is a way specifically for living things to transmit information. As a means of representation, interactivity allows recording with vital signs such as visual, tactile, among others. Data, whose values are numbers that come from sensors, and thanks to this, interactivity can give rise to invention through its current possibilities, but that have always been given by that very fundamental relationship with the environment to identify and create cultures. In explained for my words, the data is an algorithmic pattern for textiles, okay? In the same time, with a physical, portable, or surface textile. The motivation of this project that will be present in a Spain Center Cultural in Santiago, 30 November, okay, in a physical territory. Present a proposal that from a type of relationship with between ancestral craftsmanship with new technologies to be able to communicate symbolic possibilities, to give rise to a new communication interface and transmission of information, future possible patterns. Present a proposal that from a type of relationship between ancestral craftsmanship with new technologies to be able to communicate symbolic possibilities, to give rise to a new communication interface and transmission of information. For me, the information, the several information and the chaotic information is very important for to visualize on or sounds transmission, okay? Yes, an important reference for web interactivity is a Algorithmic group. This is my first idea to make a new kind of writing in a website based in a chords. The chords has an explainer, has a material-based constitution in a cosmos world. All from a post-ancestry context, because we don't have a nature as a origin cultures, but their textile techniques, I believe, very important for algorithmic works in the world. No, Chile and Latin America has a very important textile traditions, and I believe Mapuches is a very warrior culture, and because this is very difficult to dialogue with them. This is all. This project corresponds to a two more project, data visualization on textile project. The first is a triptych, consists in 3 portable bags, very little bags, based in a Raspberry Pi, in a real-time connect with a cell phone. And the cell phone transmit to website triptych, triptico.vestibles.cl, under reconstruction now, but on 30 November will be ready already, and I promote to send to you my work in this website. This is all. Thank you so much for this opportunity.
Thank you. That was such an important and a very beautiful project. Thank you for sharing. So let's have the next talk now, which is Algorithmic Pattern Cartoon 2D Animation. And this is again in Barcelona.
Thank you, Anu. My name is Roger Pibernat. I am an illustrator and also a developer of Animatron.
I'm Glenn Fraser, and I'm a programmer and live coder for the last number of years, 4 years or so, and I guess co-developer at Animatron.
Yeah, we co-developed this visuals live coding language, which can also be used without live coding. It can be controlled through MIDI or OSC. So any device that can transmit either of these protocols can be used. And the motivation after this software is I'm very lazy, but I really like animation. Animation is a lot of work. So we developed this to be able to perform animation. I once met an animator that said that it's like acting through drawing, but obviously drawing takes a lot of time. And Animatron, we're starting now to kind of research a little bit about how to chain small clips of animation. Today we'll showcase these. These are 8 clips of one variation on this cube. And with this, we'll create a matrix, and we'll show some ways, 4 ways to create patterns. One of them is to use a simple transformation on the object, so we can translate it, we can rotate it, we can change its color. Then there's offsetting the animation, like a bit after Steve Reich in phasing. He phased arpeggios. We phase animations. And after that, there's also an embedded state machine system that it makes probabilistic chains that are kind of improvised. Well, improvised. They are random, but based on some probabilities. And we made a video to showcase this because we don't have much time to live code it. And let's see how it goes. This is the matrix. This is simple transformation, just rotation the angle with an offset. This is controlled from Super Collider in a task. This is fading, the transparency. This is the offset animation, like Steve Reich. And different variations. We have 3 different variations depending on the modulus of the 16 of the number 16 and the index of each cube. Now we'll change the color. It's like a binary counter based on the iterations that it's looping on. This is a mix of color and transformation that we had at the beginning. And after this, we'll go back to the beginning and then offset with the state machines. That here, they are all sequences we haven't made random. These state machines can be changed live. I mean, if you change the state machine, it changes the sequence without you noticing it because the state machines wait for the animation to end after going to the next one. So here we had first the tongue, now it's on the top. And I think that's it. The end. wait, it's not all. Yeah. Okay. So what are the features of Animatron? As I said, we can control each of these we call an actor, and we can access its properties and its animation frames, whatever we want to affect. We can do it through OSC or MIDI messages. So it can be controlled from anywhere. It also has an embedded editor that you can write OSC messages that sends to itself. And we can create routines, a little bit like in Super Collider, that can call commands after specific time intervals. Then we have a pretty powerful, simple and powerful idea that is you can define new command messages, new OSC messages with OSC itself. And from there, it's you can create functions and embed multiple commands in your own syntax. And then, as I said, we have state machines, and also it's built on Godot, with it's an open source game engine that it works with GDScript, which is Pythonish. And it can be live coded as well. And we can create our own scripts called actions in Animatron to further modify the actors at a lower level. And this is this was built on Godot 3. Now Godot has upgraded to version 4. And we're rethinking it. And Glenn will tell you what are the new features.
Yeah, because when the underlying technology upgrades, you have to upgrade your technology. There's not really a reason why we had to go to 4, but we decided for interest and to learn and to move forward, it was a good time to sort of rethink it. So one of the things about, well, actually, I think I just reiterate what Roger just said about the defs, what we call defs, a way of defining commands. So we have sort of an underlying set of commands, and then you can build everything on top of that as like a sort of hierarchy of further commands, which is a normal programming thing to do, breaking things down into smaller pieces. And a lot of times when we're just working on something, trying to figure out how to do something, we realize, oh, actually, we can just write a command that does that. We already have, because we have enough low-level pieces, we can already do a lot with that. But right now, it's sort of limited, the sort of old version of Animatron, in terms of sort of logic, patterns, sort of the way you want to do these kind of things. Generally you rely on an external thing, like we tend to use Super Collider, which we're familiar with that. It could be any external thing that can send OSC messages. You can use whatever you want. You could use MicroBlocks or whatever, you know. And so in the new version that we're working on now, one of the things we want to be able to do is do more within Animatron itself, so that sort of logic and pattern programming. So there's an editor, which I don't think you mentioned. There's an editor that you can also directly see the code. Like you can modify the code on screen in typical live coding fashion, show us your screens. And but what we want to do is add more things, like extending the routines, for example. And the state machine right now is pretty much just animation sequence based. So you have an animation sequence, and then when that finishes, it can choose one of several others with some probability and so on. But more, in general, a state machine would have maybe entry tasks and exit tasks and things. You could have things happen when different state changes happen, or during the state, you could have sort of an update that happens during the state. And then when you go somewhere else, some other update will happen. So we don't have that right now. We just have animations. So, I mean, it's sort of a divide between I mean, Roger is a programmer also. I'm a programmer by definition, and Roger is like an artist, a illustrator, an animator, and he's become a really good programmer as well. But that's probably a little bit of a division too in how we see things too. Like you're more thinking about things, solving the problem. Like you've done so many performances with Animatron already, just with what's there, and making these incredible sort of theatrical things to accompany music, or to not just live coding, but prepared, but performed live. And the other thing we want to do is add sort of expressions, which, I mean, these are just normal programming things, but doing it in our own way. So expressions that you can add within a command. So if you say, translate to this position right now, you have to do it that way, or have Super Collider do a calculation and figure out over time, we're going to animate it, do a Lissajous pattern or something like this. But we want to be able to do that within the direct syntax and the commands of Animatron. So that's something we're working on. Yeah, so I think that's probably a good overview. Anything else you want to say? Or?
Well, I just hope that in the next version, I found out that on the previous version, on this version, it's very hard to do algorithmic animation, and that's why we decided to introduce these expression things, so we can make actual algorithmic animation, or animation algorithmically. And I think that's it for now. Hopefully, we'll have the new version out soon. And well, thanks for listening.
Thank you so much. I think in the next version, please have some chip tunes as well, in collaboration. Yeah. All right. In the next talk is Velvet Values. So yeah, please take it away, Emma. I think.
Unmuting myself, and I'm just wanting to share my screen. There we go. Thank you. So hello, everyone. I'm Emma Wood, and I'm presenting Velvet Values, which is a 3-year artistic research project I'm doing at the University of Arts in Berlin as part of the Digitized program, and it's funded by the Berliner Chancengleichheitsprogramm. I'm only a few months into my project, but I couldn't resist the chance to take part in such an exciting event. So my presentation is a general introduction to the project, my initial steps, and where I hope to go next. Velvet Values is a deeply personal project. I've been a weaver for close to 20 years now. It's my education, it's my profession, it's my identity. And in all the time I've spent thinking about the loom, preparing the loom, sitting at the loom, there's a familiarity in the act of weaving. The weaver imagines a cloth, they break it down into a weave structure, they translate this into input for their loom, they repeat the motions of winding the warp, and their body falls into a rhythmic pattern as they weave. And these elements culminate in cloth, a three-dimensional representation of all the steps that came before. Now, the act of weaving is easily identified and communicated within reason. We can reverse engineer a cloth, we can share a weave structure, but there's a separate thread that runs throughout, which is the sequence of the weaver's embodied experiences, or what I call the process of weaving. The rhythm of one's breath, the gentle resistance of pushing heddles, creaking of the loom, cups of tea, background noise, all of these things experienced by the weaver are embedded into the cloth, but remain hidden to others. So Velvet Values is an attempt to unpack the internalized patterning generated in the process of hand weaving. Over the 3 years, I'm slowing down velvet weaving, drawing out the technique, and creating a space to fully dive into the physical folds of cloth and the experiences that lie within them. But first, what is velvet and why velvet? So to put it simply, or at least simply within weave terms, velvet is a cut pile warp-faced cloth constructed from 2 intersecting warps. In this project, I'm following the European Renaissance system, where a large wooden creel sits at the back of the loom underneath a ground warp made of fine silk. The creel is then laden with 1,000 wooden bobbins, each wound with a thicker silk, which will form the velvet texture. Once the loom is threaded, the weaver alternates between weaving the ground warp and raising the bobbined velvet silk. Now, when the bobbin threads are raised, a thin metal rod is placed through the open shed and trapped in place by the weaving of successive rows. A sharp blade is passed along a groove carved into the bottommost rod, and the yarn tufts open, creating the velvet texture. And why velvet? Hand weaving velvet in this way is a time-consuming and reflective process. The weaver follows like a 2-step forwards, 1-step back kind of approach, and I find this adds another layer of interaction between weaver and cloth. Also, the components for weaving velvet aren't readily available. The bobbins have to be carved, the rods need to be cut, the creel has to be built. And this forces weaving to be slowed down further, and it emphasizes the connection between weaver and tools. And finally, there's the materiality of velvet. It's these endless vertical tufts of yarn that kind of hug each other tightly, but can also be gently prized apart. And this encourages users to literally look within it. And I'm now going to briefly present 3 experimental responses to the process of making the velvet bobbins, which I've been doing over the last few months. Bobbins have been the heart of my project so far. Over the course of the next year, I'm adapting my loom for velvet by carving 1,000 of them. And the steps to prepare the bobbins is then also repeated 1,000 times. And this nurtures the internal experiences of carving, sanding, staining, labeling, winding, and waiting. Frustration, focus, confidence, satisfaction, and more, all of this can be traced in the subtle cut marks from the tools or from the tear of the wood grain. I'm using cherry wood as the material of choice, and as my family of bobbins grows, I can see markers of time and experience in the deepening red tones. Now, the most common question I get when I introduce the bobbins is, how long does it take to make one? And the answer is, I have no idea. In the creation of a single bobbin, time manages to extend and contract, and it's all in response to mood, focus, and flow. So in a first attempt to visualize this, I created the hourless glass. 2 cola bottles were filled with leftover wood shavings and taped together, and I filled them filled them with leftover wood shavings. And this created an improvised timekeeping device. Now, when it's left freestanding, the light weight of the shavings causes them to bottleneck, and no time can pass through the hourglass. However, when it's mounted on my lathe, as I carve bobbins, the hourless glass adapts to the vibrational patterns of carving and my physical movements. And this causes the shavings to switch between kind of trickling down, pausing, or rushing forth. And it creates an externalized echoing of my internalized experience of time. So having minimal experience with a lathe before this project, my wood turning skills have grown alongside the bobbins. And in the wood curls that fall off the lathe, I can see the development of my knowledge and my confidence, and I wanted to store this and create a tangible resource I could refer back to. In the grain store, these wood shavings are parceled into jars, labeled and shelved. The grain store grows in tandem with my experience, and as I work backed, here they are, as I work backed by physical representations of my process, I feel supported by this rich store of carving knowledge that I can draw on. As with the bobbins, the cherry tones develop over time in the jars, and this creates a form of calendrical patterning, which you can see in the bottom right image. So where to now? Enough bobbins have been made for me to weave a 10 centimeter wide velvet cloth. That's 150 bobbins. And this is the place I find myself in now. And as I prepare for weaving, I'm reflecting back on what I've uncovered so far and looking for the patterns within those experiences. My data sheet, which you can see here on how each bobbin is made, has started to resemble an elongated weave structure. And in here, I can see layers of information and complexity that remind me of historical velvet notation systems. As I thread the loom, which is what I'm doing now, bobbined silk and the ground warp combine to create loose structural networked patterns that become more stable as the threading process advances, as they're pulled through the loom into their final position. And then as I work, I can see the gentle movements in the weights of the bobbins as they sway in response to our shared environment. A tug on a warp thread, my footsteps, or a passing heavy goods lorry outside. This creates motion within the weights that hang off the bobbins. So these are some of the elements I'm looking forward to carry with me in the next steps as I begin to weave the first rows of velvet. And yeah, I'm excited to see what emerges. And that's it from me. Thank you.
Thank you so much. That was really reflective and beautiful. Yeah. All right. So do we have all the speakers? Yeah, we do. So it's Q&A time, and we have some really nice questions for you, all of you. Let's start with the question for Julia. So this is from, let me show the question. Yes. Clarissa says, I'm not a crocheter, so I don't know the answer to this, but how stable is crochet under random mutation of the instructions? Would you still get stable stitches if the tactile interface was also doing some procedurally generated or randomized change to patterns?
So I actually have already randomized pattern instructions within my device, and when this happens, I can still follow it and make a crochet item, but often then this mutation kind of transforms the item into a more 3D shape. Like I have an example here, and it's like going up and transforming the device, the item, I guess. And also in times when I really think the mutation is too strong, I do make the decision to divert and be like, okay, this is not possible. I have to do something else in order to not completely be lost within the project. Yeah.
Thank you. All right. Let's take another question. This is for Maria. Do you think you'll be able to learn more things about the environment of the wearer or the life of the textile from the capacitive sensors in the textile?
Of course, it is possible. My next things about a textile project is relationship with the environment of the weather. I understand more thing about the environment of the wearer of life textile, and from the move in a when I weave them on the loom, from the capacitive sensor in the textile, of course. Yes, it is possible. Because my English is not good, okay? But
maybe it's possible for you to speak in Spanish and we can have Ivan translate. Yeah.
Yes, mira, to learn, you will be able to learn more things about the environment. Lo que yo entiendo es que, bueno, desde los textiles y la capacitividad, que es lo que yo trabajo para este proyecto, es sumamente posible los datos de lo que sea. Depende del sensor y de la capacitancia, pero sincronizada al sensor. En el textil.
I'm trying to translate it. Basically, what Maria Jose is saying is like, it is possible, and please correct me if I'm saying something wrong. There are people here looking at me. But it depends on the capacity of the sensor and also on the material. Is that correct, Maria Jose?
This capacitive sensor, what?
You said that it is possible, but that it would depend on the material you are working with and the capacity of the sensor.
Exactly. Yes, with a conductive thread and connect and synchronized with the software.
So apparently it's possible.
Great. All right, let's take a question for Bernat. Jenny Fisher wants to know where they can find more about your work.
So you can find out more about MicroBlocks at microblocks.fun. We chose this domain because com was taken and because it's fun. And also, I guess in my website, although I don't update it so often, which is romagosa.work, my surname.work. Or write to me. I'm on Mastodon. I'm B Romagosa on Mastodon.
Great. Thank you. A question from Phil Jones about the animation. They're happy that they haven't seen this kind of style done before, and they want to know, how does it look to program the state machine?
How does it look to program the state machine? Well, you just actually the actors have an associated animation, so an image sequence that it has a name, it has a string, it's the name of the folder containing the frames, and then each state has the name of the running animation at that point, and then the next state is a list of possible next animations. If you put the same name, you just loop in that animation. if you put 2 animations, it has a 50% chance of choosing either one. If you put 3, it's 33%, and so on. And so it's very easy to live code with it, because if you just know the names of the animations that are in the folders, you can just create really, really interesting sequences. I don't know if that was the question.
Great, thank you. Another question from Phil Jones, but this time for Emma, I guess. Says, not knowing anything about this weaving, does the movement of the bobbins change the pattern that's eventually produced?
So it's not so much the movement of the bobbins, but it's more about which bobbins are activated. There will be motion within the bobbins then as you're weaving, as a result of them slowly unspooling the yarn. So the way that weaving traditionally works in most setups is that the loom will hold your vertical or your warp threads at a tight tension. Everything will be quite fast. But with velvet weaving, you want to be able to create these loops. You want to be able to have flexibility in your tension. And by winding and by separating those warp threads onto these 1000 bobbins, you're able to individually control which bobbins are being activated, which ones are allowing you to lift up to wrap over a metal rod, or which ones will remain underneath, so you can create velvet patterning. So the bobbins then in that case become a vehicle for the yarn, for the velvet silk to move forward or to remain static. And in that essence, they do move, but that's more a result of them kind of being actively selected. I hope that makes sense.
Thank you. Let's take another question from Diana for Julia. So Diana would like to know more about the temporal qualities of the crochet protocol. It sounds like the user cannot move back or forward in the instruction list. So was this an intentional design decision? How do you think about supporting users making their own decisions with feelings of uncertainty they might experience if an instruction step is missed?
So it was actually an intentional design decision, because I do like this tension of having to follow the device without much like own choices. But that's also an interest I have in other projects of mine. So for this version of the protocol, I did do this intentionally. But I'm also giving, or when I'm wearing it, I'm also diverting from the instructions to make my own decisions as well. And I've been also thinking about developing it further to have a more practical device rather than this, which is focused more on the artistic side. So yeah, that's like my answer.
Great, thank you. Do we have time for one more question, or? You're muted.
Yes,
Oh, yeah,
we
there.
have another few minutes. Yeah.
Okay. So Steph wants to know that. Okay, so there is seems to be a recognition that there's women's presentations that are more linked to textiles, learning about the virtual world, texture and body through touch. And the men's presentations are almost entirely virtual, no tactile or graspable, and no feedback between lived world and virtual world. Yeah, does anyone want to answer this or take this?
We'll try. I don't know why this happens, but the idea of MicroBlocks is to make physical devices. We just got started into making music, but the original idea of the project is you make devices that you can touch and sense the real world. And also, further ideas for this project is mixing the music making capabilities and the world sensing capabilities. So you can make a device that changes pitch depending on its orientation, or the light it's receiving, or I don't know. So, but you are right. So far we've seen this pattern.
I guess one other thing I could say is that not defending anyone. It's not that kind of thing. It's interesting because like Roger and I in previous work we've done, we've always really tried to deal with more physical things like cutting up paper, cutting things, drawing things, and that's partly what I mean, one thing that we don't like, I think, as much about some digital tools is that it is purely 3D or 2D or just algorithmic in that sense, and there's no physical thing. At least Roger is like drawing things, so there is somewhere in between where we're attracted to that world. I mean, for me personally, the thing I've learned most today so far is I want to become a weaver. You know, that's what so welcoming me into your world is where I get out of that. So.
Yeah, maybe I would also just say, you know, I think, you know, my project, so much of what I want to examine is something that isn't tactile, and for me that's very unfamiliar territory to go into, and I haven't been sure of I know it's this thing of I know what I want to identify, but I don't know what I want to identify, and how do I start to find information that I can pull from. And so I'm certainly, in the beginning of my projects, I'm beginning very much with what I know, and my background just happens to be in craft and textile. So I think I'm working at the moment with a hypersensitivity and a hyperfocus on material and tangible, in this idea that if I have a broad enough canvas, if I dive deep enough, then those virtual or those intangible, those ungraspable qualities will begin to come out, because I want that. I hope I can get to a place where those things start to come out and then sit in harmony alongside the tangible.
Yeah, those are great answers.
Can I add something? I think that a very poetic counterpoint is that we are all three men here in a physical space. The women presentations are online in a virtual space, and I think that kind of unweaves, you know, the presentation. I would really like to touch all those weaving pieces, no, because they are very appealing.
Yes, Maria, you were saying something as well.
No, lo puedo. I can to speak in Spanish for to. Okay. Yo creo que la relación físico-digital es constante, sobre todo ahora que tiene que haber una simbiosis. Esa es como la naturaleza permanente actual, la simbiosis entre lo físico y lo digital, ¿no? Constantemente. De ahí está la tarea de sincronizarla o de hacer algo ahí, ¿no? Y que se tejan esos dos asuntos. Nada más.
Estás tocando un punto muy interesante. Maria Jose is saying like there is a relationship between the physical world and the digital world, and there is actually there are different ways, and maybe here I'm inventing a little bit, but there are different ways to put this to explore this relationship and to bring these two worlds together. And am I missing something? I think it's more or less. Gracias por la reflexión.
All right. We have actually one last question, and this is for Emma, and it's from Alex. So Alex loved the example of the historic velvet notation. How do you feel about considering these complex ancient technologies next to contemporary ones?
Yeah, I feel a few ways about them. I mean, firstly, I'm kind of in love with them. I mean, but I'm also in love with most things to do with weaving, so I don't think that's a huge surprise. You know, when I work with some historic jacquard, I work with historic jacquards in some elements of my work, and people are usually impressed by the huge scale of these machines and how impressive it is what the jacquards can do. And yes, it is impressive, but I also spend a lot of time explaining to people that weaving as a technology, weaving dates back to the Neolithic era. Those are our first examples of woven technology. And from its inception, it was a pretty perfect technology. And looms really actually haven't changed that much. They all are these vehicles to allow us to hold threads under tension and to raise and lower different combinations of them so that a weft thread can pass through. That is what weaving is. That is what looms are doing. And some have more bells and whistles. And what I love about these types of historic notations, like you saw in the velvet notation, is that they look very complex. You feel like you're diving into something that you can't possibly understand. At least that's how I feel when I first see them. But there's also this background knowledge that all weave structures are telling me the same thing in the end. They're all telling me which threads I'm raising, which threads I'm lowering. They're giving me order. I know what information to look for. And then it is just this very exciting journey of beginning to unravel it and unpick it. And I think my enjoyment of that really ties in with in general why I think being a weaver is good for me, because that is the entire act of weaving is you begin, and when you design cloth, you begin with your envisioned end result, and then you're reverse engineering to figure out how you're going to get there. So puzzling my way through these notations, it feels like you're stepping into history. They're unfamiliar, but you also know what nuggets to be looking for. They're codes that you get to crack. And, you know, when you see them next to these contemporary ones, it's really fascinating to see which elements we keep, which elements get translated in different ways, and which new ways people are finding to communicate complex ideas using the same framework. Yeah. So essentially, short answer, I love it.
Yeah, I was saying that's a great way to finish off for today. Thank you so much. Lots of nods and lots of claps from everyone. Yeah, thank you so much for today. And Alex promised some claps from Barcelona as well. Perfect. So thank you for today's session, and hopefully we see all of you back tomorrow. Yeah. Bye-bye.
Thank you. Bye.